we have to plot the graph of this function. This is quite an easy function to sketch, because at infinity you can see that the limit of this function at infinity are plus or minus infinity. The limit will give me 1, because the behavior of the denominator will be approximately coincident with x squared, because x squared will be much larger than 1. So it's x squared over x squared, so we get 1 at infinity. Whereas at plus or minus 1, the denominator will go to 0, right? So we are going to get something which diverges. It goes to either plus infinity or minus infinity, that depends. So we need to analyze that. And the function is equal to 0 when x is equal to 0, so the function will be equal to 0 here. And we can also try to calculate the maxima or minima of the function. So the derivative of the function is 2x times x squared minus 1 minus 2x times x squared divided by x squared minus 1 squared. So here we get that this term will cancel this one, because we have minus 2x cubed, and here we have 2x cubed, so that will go to 0, and then we have minus 2x divided by x squared minus 1 squared, and you can see that this derivative will be equal to 0 at x equal to 0. And if we study the sign of this derivative, it will be positive if x is less than 0, and it will be negative afterwards, right? Here we have x equal to 0. So this is a maximum. This is the maximum of the function. We have a maximum here, and then we can try to sketch the function. I mean, the behavior of the function here is something like this, okay? But we can see that, for example, if x is slightly smaller than 1, as x approaches 1, we are going to get 1 squared is still less than 1. So we have 1 minus 1, that's 0 minus. It is slightly smaller than 0. So we are going to get the positive quantity divided by something which is slightly negative. So we are going to get minus infinity here in the neighborhood of 1 from the left. Whereas from the right, we are going to get something which is infinite here. And then here, the function will do something like this. It will go to 1 as x approaches infinity. Okay, so this is an asymptote, a vertical asymptote. We also have an horizontal asymptote here. And at x equal to, as x approaches minus 1 from the right, in this case, we are still going to get minus infinity. Whereas from the left, we are going to get something similar. It is plus infinity, and then we get an asymptote here, an horizontal asymptote, and the function is going to behave like this. It's going to flatten out, and as x goes to minus infinity, we are going to get that this function is closer and closer to 1.